Okay, let's see. We've got that circle. Find its radius. Okay, that's pretty straightforward. Its radius would be square root 1 plus 9 minus 1, which is 3. The coordinates of its center would be at minus 1 and 3. So if I was to sketch that, minus 1 and 3 will be here, and oh, that's interesting. So it's going to touch as a tangent on the x-axis. So they want to find the length of the y-axis cut off by this circle K. So that distance there is 3. That distance there is 3. Yeah, maybe if I draw this a bit neater, I can figure it out. Okay. So the center is at minus 1, 3. It's so large. Okay, so that's minus 1 and that's 3. And the radius is 3, so that means tangent here. And the other up here at 6. Okay, and the circle is going to curve around. So yeah, actually we just need to figure out where it crosses the y-axis. That's all. And then look at the difference in the heights. So to find out where it crosses the y-axis, just make x equals 0. So you get y squared minus 6y plus 1 equals 0. Y equals minus b plus or minus the square root of b squared minus 4ac all over 2a plus or minus root 32 over 2. That's 6 plus or minus 4 root 2 over 2, which is 3 plus or minus 2 root 2. So the distance would be 4 root 3. Okay. That circle, which contains the points of intersection of K and the line Q, find the equation of Q. Okay, S is that circle, which contains the point of intersections of K and the line Q. Find the equation of Q. Okay, so we've got circle K, circle S. S is the circle which contains the points of intersection of K and the line Q. We don't know what Q is. Find the equation of Q. K is that circle. Okay, we know that. S is that circle, which contains the points of intersection of K and Q. Find the equation of Q. And show that it contains the center of S. What? This question doesn't make any sense. K is that circle. Find its radius, the coordinate. Okay, S is that circle, which contains the points of intersection of K and Q. Right, so we've got circle K. There's a line Q passing through it. And the line and S contains the point of intersection between K and Q. So S has to pass through that. So yeah, it's just a fancy way of saying that Q is a common chord. Find the equation of Q and show that it contains the center of S. But it doesn't look like Q will contain the center of S. Unless S... Could it be like this? There's K. There's Q. Could S be in... don't know. Confused by the wording in this. Just going to subtract to see what equation I get for Q. See what happens. 3x minus 3y plus 3 equals 0. So x minus y plus 1 equals 0. That's what I think Q is, but is the center of S on it? Well, the center of S is going to be minus, it's going to be a half and 3 over 2. If I sub that in, it's a half minus 3 over 2 plus 1 equals 0. So it works. But what on earth does the diagram look like? That's what I'm totally confused by. I'm going to have to draw it to see. Because you can see clearly, I drew it in such a way that Q doesn't pass through the center of S. So let's see what happens. X squared plus y squared plus 2x minus 6y plus 1 equals 0. Okay, and then the second circle, x squared plus y squared minus x minus 3y minus 2 equals 0. Oh. X minus y plus 1 equals 0. Yeah, that's how you can draw it. Yeah, so Q is the common chord and it is drawn so it passes through the center, so it can be drawn. Very interesting. Very interesting. That's a good question now, because I just yeah, I had trouble drawing it, but yeah, I guess the important thing is you have to make sure this circle's a good bit smaller than the, yeah, okay. It's a good question.